For our second informative speech, I want to discuss with everyone on the importance and value of what I do and give you a more in-depth analysis of a day-to-day function and then what can happen with my current position in a week's time manner and then up to maybe even a month. What I currently do is I am a quality engineering analyst for a company in Aiken, South Carolina called ASCO Valve. I've currently been with my position for about 8 months now. My job responsibilities include consolidating our current inspection plans, or what we call op sheets, for our go live implementation for Oracle in next spring. Oracle is going to currently replace 3 operating systems that we use for inspections, shipping and receiving, and purchasing. So what that means is we're going to go from 3 operating systems to 1. I mostly deal with the quality inspection side of the 3 operating systems that we currently use, and once Oracle goes live, that is still primarily where my job is going to be. So what it means for go live is one day, well, let me back up a little bit. Right now, we are in the process of training for Oracle. We have training every week for our planning department, for our quality department, for our shipping and receiving department. Everybody is going to get hands-on contact with Oracle before our go live. So what go live means is next spring, I think more so in March, if let's say the end of February, we have our 3 operating systems. We're working as a company, we're doing our job every day. Next day when we come in March 1st, our go live is going to implement, and what that means is we will be working with Oracle now. Why my job is so important is our inspectors are heavily reliant on our op sheets, because our op sheets are created by quality technicians and they are kind of a mirrored image of our drawings. And so what that means is a quality technician will get a drawing in front of them. They will skim the dimensions or criteria and assess it and decide what is important, what is not important. What is important goes into our current collection plan, or what we call op sheets, for our inspectors. It lists dimensions, certain gauges that can be used to check these dimensions, certain tolerances that these dimensions may have. It ultimately helps our inspectors, when inspecting the parts, know if a part is good or bad. So another example of what a QA technician will do is, let's say you have a drawing in front of you and it has a CTQ on it. A CTQ means critical to quality. Critical to quality is very important, because if a part has a CTQ of, let's say, a diameter that is 2 inches, if this diameter is not 2 inches, that part is not going to function. It is very critical that that diameter be what that diameter is supposed to be. So if that diameter is not 2 inches, like the example stated, it must be scrapped. It can't be used. It's not going to work properly in our valves or our actuators. Therefore, we could be shipping out unsafe parts if we choose to have a blind eye to it, and we don't want to do that because our reputation is on the line. So daily roles and functions of what I do is, I'd like to walk you through kind of a simple collection plan that I have consolidated and what we use in terms of generic. So a good example would be an O-ring. An O-ring looks like this. And what an O-ring is it is a gasket in the form of a ring, like that, with a circular cross section, typically made of pliable material, used to section or seal off connections in pipes, tubes, and in our case, our valves or our actuators. So what I would do is I would take all the collection plans or op sheets that we currently use in one of our operating systems for O-rings. And currently right now we have over 30 to 50,000 op sheets for all our parts that come into ASCO Valve. So what I would do is I have a spreadsheet that I look at. It tells me every single, like let's say for example like the O-rings, tells me every single O-ring part that we have. So I currently take that part number and I go to one of our operating systems and I can find every single collection plan or op sheet that we have for that O-ring. So what I do is I pull the drawing and I look at it and I analyze it. I see, okay, it has an outside diameter, an inside diameter, tells me the material, it tells me possibly a duro reading. And so what I do from there is I take all the op sheets for those O-rings and I try to consolidate them. I try to see what they have in common. What really is critical to quality, what really is important, or what could be considered obsolete. So from there, once I have all that data compiled, I then go to the senior product engineer and I show him my findings. And then we discuss, okay, yes, that outside diameter is important, or yes, that inside diameter is important, or we really don't need to know this on that, this could be considered obsolete. Because moving forward, we want these op sheets to be generic because we want our inspectors to be more reliant on the drawing. Currently, the operation system that we use now, our inspectors are more reliant on the collection plan, and these collection plans are not always accurate. So we want them to be reliant on the drawing because they're always updated with the latest revision. So next, once I've met with the senior product engineer, I then create a current generic op sheet with every single O-ring that we had an op sheet for. It now goes into this generic op sheet. Once it goes into this generic op sheet, then I am responsible for going back and also obsoleting the other op sheets. And in a way, directing inspectors, okay, you may have pulled up this op sheet, but now I want you to go to here. So I will put in the notes tab, this op sheet is now obsolete. Please refer to new generic op sheet, and I will list the title of it. However, though, there are certain parts that we can't consolidate and make generic. Like, let's say, for example, like a bonnet or a body. Those can be very intricate and very unique, meaning we may not have one that is even remotely like it. So when I get to a part that I'm analyzing like that, I usually will call the product engineer up and say, hey, this is very unique. I really think we just need to keep the op sheet that we currently have for this for Oracle. Most of the time he agrees with me. However, though, we still are able to consolidate some of the criteria down because our goal is we don't want our inspectors spending all day on checking one part. We have parts right now that has 60 to 80 criteria. That's a lot. Currently, we don't want it more than 20. So that's kind of a breakdown of what I do on a day-to-day, and this usually, in the grand scheme of things, it can take about a month to accomplish because it's a lot of backtracking, a lot of analyzing, a lot of pulling people from what they're currently doing and saying, hey, I really need your help with this. Can you help me? Why I love my job, though, is because I feel like I'm actually doing something important. I get this sense of self-satisfaction of I'm actually accomplishing something. I'm helping this company really move forward and better themselves. And I can't explain a better feeling than that. And I also love my position because I knew what I wanted to do kind of with my career. I knew I wanted to get into manufacturing. I was more set on the purchasing and procurement side, but I have found a love and quality that I really want to pursue my career with. And for that, I'm forever grateful because how many people can say, I have my degree, I know what I want to do, and I'm going to do it. Thank you.